In the last video, we talked about what an ionic bond is, and we said that it's a complete transfer of electrons. It's a bond formed when one atom gives up electrons and one atom takes electrons. There's no sharing involved. One atom is completely giving away its electron, saying, "See you later," and don't want to see you again. And the other one is taking the electrons gladly, and both atoms are happy because by giving away their electron or accepting an electron, they're doing that in order to get to 8 valence electrons. And with 8 valence electrons, they are happy. So an ionic bond, again, is a transfer of electrons. There's no sharing involved. We also said that it is typically between a metal and a nonmetal, and there's a difference in electronegativity of greater than 1.8. In this video, we're going to be focusing on this point right here, that the difference in electronegativity is greater than 1.8, and then we'll talk a little bit about it being a bond between a metal and a nonmetal. So, and we talked in last video, here's visually what's going on in an ionic bond, a complete transfer of electrons. But today we're going to be talking about ionic bonds and electronegativity. We have already covered the trend of electronegativity. Electronegativity, as a reminder, the trend is that it increases as we go up and to the right, and we're not going to worry about the noble gases because they're kind of an exception because they don't form bonds. So electronegativity is kind of irrelevant for them. But the trend is that it goes up and to the right and stops here at fluorine, where fluorine's the most electronegative element. So ionic bonds, they are typically a bond between a metal and a nonmetal. I went ahead and colored in a periodic table of just metals versus nonmetals, and then the metalloids here in the separating them. And yeah, nothing fancy. We're not separating the transition metals and alkali metals, alkaline earth metals, etc. Just metals, metalloids, and nonmetals. So an ionic bond is a bond between a metal and a nonmetal in most cases. And it also tends to follow the rule that it's the difference in electronegativity is greater than 1.8. And you might see some other values. We're going to use the value 1.8, but you might see the value of a difference in electronegativity of greater than 2.0. You might see 1.7. It kind of depends. And the reason why there's not a set value is because no bond is completely 100% ionic, and very few bonds are completely 100% covalent. So there's kind of like a range of like, is it more ionic or more covalent? There's kind of like this scale of like, where does it fall on between ionic or covalent? And whether it falls more to the ionic side or covalent side. But in this level of chemistry class, we're just going to be characterizing things as either ionic or covalent because that's typically how we'll describe things. But just to let you know that if something's ionic, that doesn't mean it's 100% ionic. It might have some covalent properties. So we're going to use this cutoff as value of 1.8, and if a value is greater than 1.8, then we're going to say it's an ionic bond. If it is less than 1.8, we're going to say it's not an ionic bond, and it will probably be covalent bond. But we'll talk about covalent bonds in another video. But today we're focusing on whether it's ionic bond or not an ionic bond. So the examples that we covered in the last video were sodium chloride and sodium oxide. Those were two examples that were covered in the last video. So we'll talk about those here. So we said that an ionic bond has a difference in electronegativity of greater than approximately 1.8. And instead of using the periodic table that I have been using before, where I have, the atomic number and atomic mass and element symbol and whatnot, we're looking for the electronegativity values. That's what we're using for this right now, at least. So, I pulled up a different periodic table that's, instead of showing the atomic number, we don't need the atomic number for this. We just need the electronegativity values. So just a little more, looks a little bit more clean, where it shows you the electronegativity value in the element symbol. And feel free to use. I'm gonna let you use electronegativity tables on pretty much all future tests and quizzes going forward. So electronegativity, again, the trend is up, goes up and to the right. It stops at the noble gases. What exactly it is covered in a different video. But sodium has an electronegativity value of 0.9. So we find sodium on the periodic table. It has a value of 0.9. Chlorine has an electronegativity value of 3.0. And those are the two elements that make up the compound sodium chloride. So all we're going to do is we're going to find the difference in their electronegativity values. And the way to do this is to take the biggest number minus the smallest number. So there's only two numbers ever between a bond. And take the bigger value minus the smaller value. So 3.0 minus 0.9. And it gets us 2.1. The reason why we want to take the bigger value minus the smaller value is so that we never get a negative value. Alternatively, you can use an absolute value when you're doing the subtraction. It doesn't matter the order then, but if you don't know what an absolute value is, then just take the bigger number minus the smaller value, and then you are always going to get a positive value. So we take 3.0 minus 0.9, and we get a value of 2.1. And then all we're going to do is compare that to the value that we set of 1.8. 2.1 is greater than 1.8, and therefore the bond is ionic. So all we did was look at the electronegativity values, take this bigger number minus the smaller number between the two, and see what that value is, compare it to 1.8. If it's bigger than 1.8, if it's greater than 1.8, the bond is ionic. If it's smaller, then it's not ionic. All right, next example. We've got sodium oxide, Na2O. So again, sodium's electronegativity value is 0.9, and oxygen's electronegativity value now is 3.5. So we're going to do the bigger number minus the smaller number. Typically, that's going to mean the elements further to the right minus the element that's further to the left. And we're going to get 3.5 minus 0.9 equals 2.6. What are we going to do with this 2.6 value? We're just going to compare it to our value of 1.8. If it is greater than 1.8, then the bond is ionic. If it is less than 1.8, the bond is not ionic. 2.6 is greater than 1.8, so therefore the bond is ionic. And then I put one more example in here, a molecule that's a lot of us are probably familiar with, CO2. That's the air that we breathe out. We breathe in O2 and then we exhale CO2. So something we're probably familiar with. So CO2, it just as some more background, it looks like this. Oops, it's not bent. It's C. In case you're curious, looks like this. And the bonds, we're talking about these bonds between the oxygen and the carbon. So is this bond, and bonds are represented with lines typically. So this bond between oxygen and carbon, or this bond, or this bond, or this bond, they're all going to be really pretty much the same, or they all are the same in this sense at least. So are these bonds ionic or covalent? That's what we're trying to figure out. So we're going to take the value of the one element that it's attached to and compare it to the electronegativity value of the other element that the bond is attached to. And we're going to see if that value, if the difference is greater than 1.8 or less than 1.8. So we have oxygen, we already said, has an electronegativity value of 3.5. And we're going to compare that to carbon that has an electronegativity value of 2.5. So we will do the bigger number minus the smaller number, 3.5 minus 2.5, and we will get 1.0. All right, so we're going to compare 1.0 to 1.8. And since 1.0 is less than 1.8, that means the bond is not ionic. And specifically, this is a covalent bond. But we'll learn about covalent bonds, and then we'll learn about another bond called metallic bonds in a later video. But for right now, we're just focusing on, is it ionic or not ionic? And this one, since the value is less than 1.8, it is not ionic. And that's all I got for this video. We're going to cover more topics concerning ionic bonds in the next video.